Welcome to the Making Sense podcast. This is Sam Harris. Today I'm speaking with Chris Field. Chris is the director of the Stanford Woods Institute for the Environment and the Melvin and Joan Lane Professor for Interdisciplinary Environmental Studies at Stanford University. Prior to his appointment at the Stanford Woods Institute, Chris was a staff member at the Carnegie Institution for Science and founding director of Carnegie's Department of Global Ecology. Chris's research has focused on climate change. He is a very influential scientist in the field, widely cited. He's especially focused on solutions that improve our lives now and decrease the amount of future warming. He's been deeply involved in the national and international efforts to advance our understanding of global ecology and climate change. Chris has also overseen many of the efforts of the Intergovernmental Panel on Climate Change, as you'll hear. He's also been elected to the U.S. National Academy of Sciences, the American Academy of Arts and Sciences. He's received the Max Planck Research Award, among others. And he holds a bachelor's degree in biology from Harvard and a PhD in biology from Stanford. Anyway, I wanted to get Chris on the podcast because I wanted a sanity check, frankly, about climate change. It had been a couple of years since I'd done a podcast on the topic. We are now in a political season where Republican candidates for the presidency can be heard saying things like the climate change agenda is a hoax. So I just wanted to get a top-flight research scientist here to articulate what the mainstream scientific consensus is on climate change, our contributions to it, the promise of mitigating it, what the future is likely to look like, etc. Obviously, this is another PSA, so no paywall. But if you want to support the podcast, the way to do that is to subscribe at samharris.org, which makes all of this possible. And now I bring you Chris Field. I am with Chris Field. Chris, thanks for joining me.
It's my pleasure. Thank you.
So we're going to talk about climate change, what we know about it, what we don't know about it, what many of us refuse to know about it. But first, describe your background. What work have you done on this issue?
My degrees are in biology, but when I started my academic career, I turned really right at the outset to trying to understand big picture issues of how global change was altering ecosystems, altering biological diversity, altering plant growth, and just changing the natural world. Most of my early work in this space was experimental and spent several decades doing experiments, especially at Stanford's Jasper Biological Preserve, where we altered the environmental conditions for entire chunks of grassland ecosystems. We changed the concentration of carbon dioxide in the atmosphere. We changed the amount of rainfall. We changed the temperature that the ecosystems were going into and had a front row seat for looking at what happened to ecosystems when they were exposed to the kind of climate conditions that we expect in the future. In parallel with that work, my group started doing assessments of what we know about what's happening with the global carbon cycle, and in particular, why ecosystems on land have been so successful at taking up a large fraction of the carbon dioxide that's emitted from fossil fuel combustion. That work led to a whole bunch of different characterizations of plant growth across the entire biosphere, covering not only the land, but also the oceans. Around the time we started doing these global scale synthesis, I also got involved in the Intergovernmental Panel on Climate Change and found that just a wonderful opportunity to broaden my understanding and my perspective. So for the IPCC fourth assessment report, I was what they call the coordinating lead author, the person in the crosshairs for the chapter on North America, where we tried to assemble basically everything that's known about climate change impacts expected on North America, what we can do to adapt, who's vulnerable and who's not. And then for the IPCC fifth assessment report, which was published in the 2013-14 timeframe, I served as the co-chair, the person in the crosshairs, for the whole report on impacts, adaptation, and vulnerability, and really, again, had the bird's eye view of everything that we know about climate change impacts around the world. Since the IPCC era, which really for me ended in around 2014, I've been focusing on climate change solutions, natural climate solutions, how we can take better care of our soils and forests and oceans, and on technology-based solutions, how we can more rapidly transition to an energy system that doesn't emit greenhouse gases.
And what's your current position at Stanford?
Well, my main job is that I'm director of the Stanford Woods Institute for the Environment. And for nearly 2 decades now, the Woods Institute has been incentivizing members of the Stanford community, faculty, students, neighbors, to be involved in interdisciplinary, solutions-oriented research about critical environmental issues involving climate, food, water, health, the oceans. And it's been a wonderful opportunity to build bridges between researchers, to help people observe and discover new aspects of their work, and to really push the frontiers and what I think of as laying the foundations for Stanford's bold new investment in the Stanford Doerr School of Sustainability.
John Doerr gave a very big grant to Stanford, didn't he?
A large gift, a transformational gift, and it's one that I am confident is really propelling Stanford not only to the front ranks of university, but to the front ranks of leading progress in tackling the climate crisis.
Well, I want to talk about the science and the mitigation solutions, and really, I just want to track through all that we know about this. But I want to start with some of the skepticism that all of us perceive, certainly right of center on the political landscape. And so if you're just a consumer of media at the moment, the moment you tack right of center, you meet a fairly pervasive concern that our climate problem has been overblown, right? There's this sense that there's this new catastrophism, there's an anti-capitalist agenda, there's a new religion of fear and guilt, complete with its priests, and we have, for all intents and purposes, what appears to be an emotionally vulnerable teenager serving as a Joan of Arc character for this movement. And I'm referring, of course, to Greta Thunberg. And and the optics of all of this, whatever good that has accomplished, real or imagined, on the left, on the right, the optics are quite a bit different. And as far as I can tell, many skeptics seem to believe at this point that they're on very firm ground in saying that our models for climate change going back decades have been basically wrong. So I want to start there. How have our models looked, and to what degree have they been borne out over the last 30 or 40 years since we've been articulating them? What, if anything, have we been wrong about up until this point, and just how solid has the story become in recent years?
Well, let me start out with a brief comment about the history of skepticism about climate change. And as Naomi Oreskes has documented in her really brilliantly researched book, the history of skepticism has deep roots in interests that have been opposed to transitioning away from fossil fuels. But it really got going in an era when we really couldn't concretely document that the climate was already changing as a consequence of human actions. And back in the 1980s and the 1990s, we had a solid theoretical understanding of where we were headed. We could certainly see the concentration of greenhouse gases in the atmosphere increasing, and it was getting warmer, but it wasn't getting warmer in a way that was right in your face for people around the world. But we also weren't seeing dramatic changes in the frequency or severity of extreme events. And since about 2010, that's really dramatically changed. And almost everyone has a personal experience with the fact that the climate is different now than it was only a few years ago. Many more heat waves, many more examples of heavy precipitation, the exact kinds of things that the climate science community has been predicting for decades are really playing out in real time. And if you look at the predictions from, for example, the IPCC, what you see is that the central forecasts of where we would be with temperatures in the 2020s that the IPCC made in 1990 were bang on. There really hasn't been any systematic problem with any of the calculations. And it's important to understand why this is. The fact that carbon dioxide, greenhouse gas, has been understood since the middle of the 19th century. In 1896, the brilliant Swedish chemist Svante Arrhenius published a paper where he knew in 1896 that the three things you need to do to make a accurate forecast of how much increasing CO2 changes climate. He knew that carbon dioxide is a greenhouse gas. He knew that a warmer atmosphere will hold more water vapor and that increase in water vapor will amplify the warming effect of the carbon dioxide. And he knew that over the course of several decades, CO2 that's added to the atmosphere gradually partitions between the atmosphere and the oceans, so that eventually about 80% of it ends up in the oceans. With those three things, he was able to make a back-of-the-envelope calculation of how much warming we'd expect with a doubling of carbon dioxide. He didn't get exactly the right answer, but it was pretty darn close. And that was, 127 years ago. And in that 127 years, the science has only gotten more and more solid on those foundational elements and on the interactions that mean that the actual outcomes might be somewhat worse or somewhat less bad in particular locations.
So, one problem here, it seems to me, is that the magnitude of the change just doesn't sound that bad to most people. Anyone who's steeped in the science, as we're going to show here, learns how to interpret these numbers. But, if you just told me in my naive state that 30 years from now, my children would be living in a world that is on average 3 degrees Celsius warmer than it is now, it's not immediately obvious why that would be such a bad thing. If you don't like the heat, you can move a little north. Yes, some people are going to
air conditioner.
Sure. Yeah, some people are going to lose their beach houses when the sea levels rise. Life in Bangladesh isn't going to be so great, but life in Bangladesh has never been so great. So it's easy for people to just log this whole concern as nothing more than a hypothesis, and the knock-on effects of these global mean temperature changes are at best speculative and sort of hard to worry about. How would you address that intuition?
Well, there are a bunch of elements to the narrative that you just spun out. The first is that a small amount of warming, particularly when described in Celsius degrees, doesn't sound like much. And I think it's useful to talk in Fahrenheit degrees, where each Fahrenheit degree is, of course, 1.8 Celsius degrees, and makes it clear that these are real numbers. They're easy to measure. And I think what is probably the most important fact for people to understand is that an average warming of 2 or 3 or 4 degrees Fahrenheit is not going to be existential for most people in most places around the world. But the increase in the frequency and the intensity of extreme events has the potential to be the kind of extreme heat that we saw in Phoenix this summer, for example, or the kind of heavy precipitation that we saw with the devastating floods in Pakistan last year. Those are good examples of the kinds of events that we have high confidence are connected with warming. And we know that not only with a warmer climate do we automatically see more extremes just because we've shifted the center of the distribution of climate outcomes, But we also know that a warmer climate has mechanisms that are making it more variable. So those two things really push us into a situation where we're really spending a huge amount of time and effort and money preparing for extreme events and coping with the consequences of extreme events. But I do want to address another aspect of your question about the sense of overplaying the catastrophic consequences. And I don't think you see that from the scientific community, but there are lots of descriptions in the public narrative that over dramatize the kinds of impacts that we can expect, particularly if we do a good job of tackling climate change and limiting warming to something like the goals of the Paris Agreement, well under 2 degrees Celsius or about 3.5 degrees Fahrenheit. And if we can be successful at limiting the warming to that range, we'll see impacts that are existential for some regions, low-lying islands, coastal areas around the world. Many people will die unnecessarily as a result of the exposure to high temperatures or being caught in a wildfire that's climate stimulated. But those aren't conditions that are likely to be existential for humanity or for society or for the global economy. They're conditions that we should be avoiding because we have the potential to do that. It's smart, it's affordable, and it will provide a better quality of life for citizens around the world. But that's different than saying, unless we drop everything and focus solely on climate tomorrow, civilization will disappear at any given date. This is a complicated, important, critical to address problem because it has lots of leverage on the future, not because we're on the edge of a precipice that's likely to be civilization ending.
So I want to ask one more question in a skeptical vein here, because you just mentioned wildfires, and we're having this conversation with wildfires raging in various places. And much of this in the media gets attributed to climate change. There's just a very straightforward claim that this is evidence of climate change. This is a consequence of our irresponsibility on this issue. And so we have fires in Canada and Greece and recently Maui raging to great effect, and with attendant loss of life and massive amounts of pollution. But then I read in the Wall Street Journal that this is really just false reporting, that this is much more of a story of failures of forest management and fire control and even arson. And in fact, the percentage of the earth that burns each year has declined steadily since 2001, right? So that the last 2 decades has not been a story of increased wildfire consequence globally. In fact, there's been a reduction there. So again, this is just the kind of the muddled message of what is real.
Well, wildfires, critically important issue, horrendous impacts on the affected communities. Your heart just has to go out to the people of Maui, Paradise, Santa Rosa, all the communities that have been affected. And the wildfire story has a whole bunch of different pages. It is certainly true that the global area burned in wildfires has gone down consistently over the last couple of decades. That is entirely a story of African savannas. 3/4 of the global area that burns every year burns in African savannas. Those are mainly related to agricultural practices and rangeland management, and those practices have been changing. At the same time, if you look at regions like the Western United States, been a dramatic increase in the area lost in wildfires, and we've seen that in many regions of the world, including the Mediterranean and in Australia.
Okay, sorry. So there's been an increase in the Mediterranean and Western North America, but there's been a massive decrease in Africa?
In Africa.
Okay.
In Africa. And,
Right.
and the African fires are almost entirely savanna fires, grassland fires, and of course the consequences for recovery for the global carbon cycle are much different for these grassland and savanna fires than they are for forest and chaparral fires like we have in North America. But it also is true that there are a number of factors that have contributed to the increase in fire risk in many of these fire-prone ecosystems. In Western North America, we know that decades of fire suppression allowed the accumulation of large amounts of highly flammable material. And we know that in Western North America, there's been a huge influx of people into what we often call the wildland-urban interface, but into forested regions that are susceptible to wildfire. And those two factors, when coupled with the increased tendency for these forests to generate unmanageable conflagrations as a result of climate change, has really changed the picture. And in Western North America, especially in California, we really have seen a transition from fires that were manageable in a kind of professional fire sense, even though occasionally they had devastating consequences, to fire behavior that's really unprecedented. And it has resulted in a huge increase in the area burned and a frustrating and devastating increase in loss of lives in wildfires. And with any particular fire, it's hard to know what the contribution of climate change was until it's been thoroughly evaluated. I think with the fires in Maui, we still don't have a clear picture.
Okay, so let's track through this somewhat systematically here. And what I'd like you to do is demarcate what is totally uncontroversial from a scientific point of view from the gray areas, because insofar as there's a through line here that is analogous to the claim that smoking is bad for your health, something that's totally non-debatable at this point in medicine, I want us to keep that in view. And then when we wander off of that level of certainty, I'd like us to flag it. So just to begin with, how are global temperatures measured? How are we getting this data? And what, if any, are the main sources of uncertainty with respect to the measurements and the models we're developing as a result of them?
We have a really accurate record of global temperatures going back to the latter decades of the 19th century. Around 1880, we had a sufficient number of carefully instrumented and observed weather stations and ocean observations to be able to develop a high confidence record of global temperatures. And that core record, which is now maintained in a bunch of different research institutions, is based on tens of thousands of thermometers, there are millions of ocean observations, and just an incredibly carefully curated record. And there's been a huge amount of scholarship in figuring out what happens when the area urbanizes around a weather station, and there are gaps in the record. And all of that has been really super carefully filtered out so that the different groups that are doing the analysis, including one really prominent group that's based at UC Berkeley and started out to prove that the instrumented temperature record wasn't all that great, ended up demonstrating that it was spectacularly good. And they got exactly the same thing as NASA and the UK Met Office and the other groups that are doing the temperature records. So we have basically thermometers that have been deployed around the world that have been measuring temperatures of air and ocean water for about 140 years. And those are increasingly augmented with satellite data. For a while, there was a thread running through the skeptical climate science literature that the satellite data wasn't showing the same amount of warming that we were getting with the surface observations, and that there must be something wrong with the surface observations. But it turns out that once the orbital dynamics of the satellites were understood and appropriately corrected, that the temperature record from the satellites is essentially identical to the temperature records from the thermometers. So we now have not only these instrument records and the satellite records, but we have literally tens of thousands of different kinds of ecosystem markers that are telling us the same thing. We have things like flowering dates of different plants. We have the hatching and nesting dates of birds. And these observations around the world really paint exactly the same picture, a picture where we have seen to date a warming of a little more than 1 Celsius, about 2 degrees Fahrenheit over the last century, and a warming that has rapidly accelerated since around 1990.
Mm. And how do we differentiate the natural climate variability from human-induced change? I mean, obviously the climate has changed over its history, and we have some record of that. And I guess I could also add the question here, how do current CO2 levels compare to historical levels? Do we actually think we know the percentage of change that is human-induced at this point?
In the CO2 concentration and in the temperature, we have a good record of both. So this question of what historical variability will look like, of course, is quite different if you look on different time scales. We have good records of temperature that we can extend back the order of 1,000 years based on something that feels like instruments, and can have high confidence that the instrumented temperature is now the highest it's been in the last 1,000 years or so based on that. We also have really excellent temperature proxies from ice cores that have been extracted from the Greenland ice sheet or from alpine glaciers around the world or from the Antarctic ice sheet. And depending on the resolution that one wants, we can get annual resolution back thousands of years from the Greenland ice sheet or almost 1 million years from the Antarctic ice sheet. And across all those records, what we can see is that there have been periods when the climate was very different than it is now. There was a period around 7,000 years ago that was comparably warm to what we're seeing now. And there have been many periods when the climate was substantially colder, ice ages, over the last several million years. And we understand a lot about what's causing those. In fact, some of the best evidence that carbon dioxide drives changes in climate comes from reconstruction of what happened during the ice ages that the Earth has gone through for the last several million years, and for which we have these really good ice core temperature records for about the last 800,000.
And you said we've experienced slightly over 1 degree Celsius increase in mean global temperature over the last century, so just shy of 2 degrees Fahrenheit. Is that right?
Yes, right around 2 degrees Fahrenheit.
And as far as the model's predictions from here, what is predicted, and are there competing models? How much variance is there between models, or is there a real convergence with respect to the scientific picture here as far as the possible range of temperature increase we can expect, I guess, bounded by the most aggressive conceivable mitigation strategy versus our just living in a business as usual, racing toward the brink style of increased industrialization and zero mitigation? What's expected?
Well, what we know now is that the biggest source of uncertainty in the decades ahead is what we do. And there's a huge difference between a world of ambitious mitigation where greenhouse gas emissions are tackled aggressively, brought down to zero, and the greenhouse gases already in the atmosphere are removed. And the kind of opposite, a world of continued high emissions where countries, companies, individuals decide that they're not going to tackle the problem and continue to invest heavily in infrastructure and utilization of fossil energy, of emissions-intensive agricultural techniques and clearing of forests. And with the most ambitious conceivable actions, we can limit warming to somewhere in the range of 1.5 to 2°C. The Paris Agreement says we're committed to limiting warming to well under 2 degrees Celsius. And in the world of continued high emissions, we might see a global average temperature in 2100 between 4 and 5 degrees Celsius warmer than pre-industrial. Now, one really dramatic, amazing, and encouraging sign is that 10 years ago, it looked like we were on a trajectory to be in this world of continued high emissions. In the IPCC literature, it's called RCP 8.5, representative concentration pathway, with 8.5 watts per square meter of additional climate heating. And that was designed as a picture of a world where there were no constraints on using fossil fuels, no particular progress in limiting them, and no real effort to turn away from a high emissions lifestyle. When we look now at where we're headed in a kind of a most likely outcome, the estimates range from this Paris compliant 1.5 to 2°C to more like 3°C globally. That's a dramatic progress. And in some sense, you can say, wow, we've already solved maybe 25 or maybe even 25% or maybe even a third of the total climate problem as a result of technological progress and policies that have been implemented in the last decade or so. And it is really remarkable progress. And it's an documentation that meaningful change can come from modest deployment of things that we already know how to do and are affordable. I think that that's in many ways the undersung triumph of the transition to a sustainable world, is that we have moved dramatically away from this RCP 8.5 world of continuing high emissions.
Well, I want to talk about the details of what it would take to transition further into a low-carbon economy. But before we do that, let's talk about some of the feedback mechanisms here, because some of them are pretty surprising and even perverse. For instance, water vapor is a greenhouse gas, and yet certain forms of air pollution have a net cooling effect, right? So do we want less water vapor and more sulfur dioxide and soot in the atmosphere? I mean, it's just there was just a piece published in the New York Times today, citing, I believe, a paper in Nature from, I think, last year, that claimed that without all of our industrial air pollution over the last century, the temperature increase would have been 30 to 50% higher, right? Because all of these polluting aerosols exert this cooling effect by reflecting sunlight back into space. And yet we know that air pollution, it's estimated, kills around 10 million people a year, right? So air pollution is a major concern in its own right. And it's also true that the air pollution and the greenhouse gases are produced by the same behavior, but it's just, there's this perverse fact that if we just got busy cleaning up the pollution side of it, we could expect more warming. And it just seems like a terrible outcome. And it even has, I think, like locally concentrated implications. So where, if you really clean things up in India, say, India would experience, extreme heat events, even worse than they otherwise would. Can you talk in general, I mean, feel free to address that specific case, but can you talk in general about what we know about the feedback loops in the climate system and how they complicate the picture here?
It's important to recognize that there are many climatically active substances. Water vapor is a powerful greenhouse gas, and the effective extra water vapor that stays in the atmosphere as a consequence of warming from carbon dioxide is really substantial. It amplifies the warming from CO2 by more than half. But it's not like we can regulate that. The amount of water in the atmosphere is controlled by the temperature of the air. A warmer atmosphere holds more water vapor, and there are vast areas. 70% of the Earth is ocean, and the water is freely evaporating into the atmosphere. And so you can think about it as a kind of vicious cycle feedback, that the more CO2 is in the atmosphere, the warmer it is, the more water vapor the atmosphere will hold, and then it makes it warmer still. So water vapor is simply a part of the system that amplifies the effect of carbon dioxide. There's one important wrinkle on that, and it's that water vapor doesn't get very much into the upper layers of the atmosphere, the stratosphere. And one of the reasons that the emissions from jet airplane travel are so important for climate is that jets deliver a substantial amount of water to the stratosphere, where it has this warming effect and stays in the atmosphere longer than it would if it was at lower elevations. So water vapor, super interesting, important, and except for the wrinkle about jet airplane travel, is not a lever about climate that we can control. But we're always going to see this amplifying effect of water vapor. Air pollution aerosols have the effect in general of reflecting sunlight back into space, resulting in conditions that are cooler than they would otherwise be. But air pollution aerosols are devastating for human health around the world. Millions of people every year die as a result of exposure to air pollution. And a critical priority for environmental action is to find a way to decrease this pollution, recognizing that if we were dramatically successful at decreasing levels of aerosols, we would end up with climate conditions that were substantially warmer in some places. And it is also the case that the aerosol effects tend to be quite local, because the lifetime of most of the pollutant aerosols is very short, a few hours to a few days, as opposed to centuries for carbon dioxide. With carbon dioxide, the climate effects are felt everywhere. Aerosols tend to be much more local. So that means that, as is the case for water vapor, that their aerosols don't make the job easier, but they still point a path to a solution. And we need to clean up the air pollution that's responsible for all these deaths. And the biggest problem areas are emissions from coal-fired power plants and emissions from diesel engines. We know how to address both of those with renewable energy to make more progress. And we need to recognize that as we do that, we'll save millions of lives, but we'll have to work harder and faster on decreasing emissions of greenhouse gases, because the aerosols have been hiding some of the greenhouse gas effect. Let me mention one other aspect of aerosols that people are increasingly beginning to discuss. We know from observations of air pollution aerosols from power plants and stuff, and especially from historic volcanic eruptions, that injections of large amounts of aerosols into the stratosphere at elevations of 12 to 20 miles above the surface can produce a significant cooling of climate. The Philippine volcano Pinatubo that erupted in 1991 resulted in a global cooling of nearly 1 degree Fahrenheit for about 2 years as a result of putting large amounts of sulfur dioxide into the stratosphere, producing aerosols that reflected sunlight and cooled the planet. And there have been many calls for exploration of whether we might want to use this. It's often called solar geoengineering or solar radiation management to prevent some of the warming from occurring, even at the same time we're recognizing that that's not a comprehensive solution to climate change. The idea of injecting essentially air pollution into the stratosphere is that that's a part of the atmosphere which is not primarily influencing people's health, and where, because of the way the atmosphere works, material in the stratosphere stays there for 1 to 2 years, and the quantity that you would need in order to have a significant effect on climate would be much less than the quantity that would have the same effect closer to the surface.
Is there much energy behind that as a mitigation approach at this point? Or is that just
It's
a kind of Faustian
discussed.
bargain that we don't really want to think about?
Well, the U.S. Office of Science and Technology Policy recently released a report recommending that the U.S. government invest in understanding whether or not this kind of solar geoengineering is worth considering. I'd say we're at the very early stages, but at the stage where there have been in the order of 2,000 scientific papers published on how it would work, what the risks might be, what the social and political dynamics might be associated with it. So there are tons of things we don't understand, but it's increasingly coming into focus as what you might think of as an emergency action for dealing with overshoot.
So what do you perceive to be the most important challenges in our transition into a truly sustainable, low-carbon economy? What are the major impediments at this point?
I think the biggest challenge we face is the challenge of building a durable political coalition around action on climate. The Inflation Reduction Act and the Bipartisan Infrastructure Law and the CHIPS Act from the Biden administration have all put large amounts of money out there, and we're beginning to see real progress as a result of deploying those funds. But we still live in a world where the results of the next presidential election could knock a whole bunch of those policies and knock a bunch of that funding out of the arena. And I think for entities that need to make long-term plans, utilities, auto manufacturers, energy producers, it's really important to have a predictable landscape for long-term investments. And I think that without a durable political coalition around action, we'll continue to operate much more slowly than we should. And I think there are some key features of this durable political coalition that we haven't yet tackled with the seriousness that we need to. One is what happens to the individuals and the communities that are negatively impacted by action on climate. What happens to coal mining communities? What happens to oil and gas producing states? What happens to the nations that depend on exporting fossil fuels for their economic viability? And those questions need to be answered in a much more serious way than they have been now. I think there's serious questions about the inequalities and injustices that are introduced by action on climate that need to be dealt with. And there's serious questions about how we're going to think about balancing diverse interests that are aligned on many things, but not perfectly aligned. And one of the cases where we see the kind of challenge that I think is going to be really important for the future and really needs to be solved is all of the controversy over the siting of offshore wind power installations. Everybody's in favor of offshore wind except where they see the windmills, or in favor of utility scale solar except where it has the potential to alter the migration of a desert tortoise or impact a endangered species. And those concerns are really important. They can't be dismissed out of hand. But we need to figure out some way to make progress around these barriers that are, in most cases, purely in the human dimension. It's not that we lack the technology or that we don't have the engineering capability to deploy a solution. It's that we haven't got the political and financial landscape laid out in a way that lets us make progress.
Well, it seems to me that a lot of the politics is driven by this claim, either implicit or explicit, that the consequences of really transitioning to a low-carbon economy would be economically ruinous, right? It's just way too expensive. Our economy requires continuous growth. I mean, it's really, all of our systems and institutions assume continuous growth. It's really almost a Ponzi scheme, and the renewables really aren't up to the task of providing all the energy we need. There's this piece about nuclear that I'd love you to address because, it seems like nuclear needs to be part of this conversation, and we're really, we really haven't done what we've needed to do to build, new generations of nuclear plants. So there's sense that it's just it'll be too costly to take this message, this imperative really to decarbonize seriously, especially in the developed world, places like the United States and Europe. And then when you look at other countries in the developing world or between the developing world and the most developed places, places like India, it seems a species of first world cynicism to say that they need to be thinking about their carbon footprint when they simply are following the industrial path that we in the developed world followed toward prosperity, right? So we're demanding of them things that we didn't do ourselves. And then there's the question of, how to actually make that demand and incentivize them, appropriately, ethically, and politically. So how do you respond to that arguably disjointed set of concerns about just the cost of all of this, both, in the developed world and in the developing world?
A few years ago, it was really unclear how we would ever bring emissions of carbon dioxide, especially, down to zero. But now there are really clear pathways that combine being equitable, affordable, reliable, and safe. And I hope it's well known that electricity from photovoltaics is now in almost every part of the world cheaper than electricity from fossil. And we've learned a huge amount about how to integrate large amounts of renewable electricity into the grid and are making really impressive progress in figuring out how to combine renewable sources into a truly reliable system. But there are big problems with, it's called intermittency, with what do you do when the wind's not blowing or the sun's not shining? And if we were going to deploy expensive lithium-ion batteries to be the source of electricity when the sun's not shining, it would be terribly expensive. But there are a whole bunch of strategies we can use to provide the kind of reliability in the electrical system and in transportation and in manufacturing that we need. One set of options does involve power from sources like nuclear. Nuclear is non-emitting, and we have many countries that are reliant on nuclear and have been for decades. There are obviously profoundly important questions about the safety of nuclear, about their connection with weapons proliferation, and about the susceptibility to terrorism. But there's also a lot of progress being made in nuclear. And my personal feeling is that it's important to encourage that progress, even if it turns out that nuclear can't compete on price. And at this point, the impression I have is that nuclear will have real trouble being competitive in most parts of the world because renewables are so cheap. One of the challenges with nuclear is that every increment of extra nuclear power you add to the grid is an investment of hundreds of millions of dollars, and it's hard to experiment and try different things when each increment is so expensive. The nice thing about photovoltaics and windmills is that they can scale in tiny little increments. Another feature of the future energy system that I think we need to think really seriously about is continuing to use fossil fuel resources, but connect them with carbon capture and storage. We know how to capture carbon dioxide and compress it and pump it into underground formations. That's one of the main techniques we use for extracting oil and gas now. And we know how to run a power plant with CO2 capture. We know how to run a biofuels plant with CO2 capture. And especially at the margins where we're trying to figure out how to provide that last increment of reliability, how we're trying to fill in the gaps where the renewables aren't working, we have lots of potential for using, especially for countries that already have a lot of deployed infrastructure, fossil with CCS. And then an area that I think is incredibly exciting and really has the potential to map out the bridge from where we are now to a system that's fully based on non-emitting technologies involves hydrogen. Currently, we make hydrogen from natural gas, and the way you make hydrogen from gas is the carbon part of the natural gas goes into the atmosphere as CO2 when the hydrogen gets used. We could capture that carbon and pump it into underground reservoirs. That's often called blue hydrogen. And then we can use the hydrogen to make electricity, either by burning it or by running it through a fuel cell. But we also know a lot about how to make hydrogen from electricity by splitting water. That's currently quite a lot more expensive than making it from natural gas, but we're seeing progress there. And once we have large amounts of hydrogen available, we can use that hydrogen as the equivalent of a gigantic unlimited battery and use the hydrogen to make electricity when the sun's not shining, use the sunshine to make hydrogen when the sun is shining. And the pathway that looks to me the most attractive for this transition to a truly non-emitting energy system is to take advantage of our ability to make blue hydrogen now, hydrogen from natural gas, capturing the CO2, so it's a non-emitting. And then as the cost of making hydrogen from sunshine, from electricity goes down, we can transition over to that. It's going to take decades, but that's a pathway that looks, at this point, like it'll be cheaper than continuing to get energy from fossil fuels. You look across the transportation and manufacturing and electricity spectrum, there are lots of details that need to be worked out, and there are some new technologies that are needed, but the new technologies aren't the limiting factor at this point. We have access to a lot of amazing technology now that can get us a long way to the solutions. I'd like to say a couple things about your comment about what should be the timing for the engagement of countries that are not the richest, and including countries that are the poorest. And there is a strong motivation that the wealthy countries should be leading the transition. They're the ones that are responsible for the historical emissions. They're the ones that have the economic resources to make the transition. And they also are the ones that have the finances to make it affordable. And as the non-emitting energy sources become the cheapest sources and the most reliable ones, they'll be increasingly attractive in the developing world. With the middle-income countries like India and China that clearly want to be leaders in climate-responsive space, there are lots of opportunities for them to invest in new technologies now, but they also will be slower than the richest countries simply as a result of the fact that they don't have the full kind of capabilities that we have. And we're going to need to think really hard about how the rich world interacts with the poor world in terms of driving the energy transition. There are kind of two models you can think about. One is that in the rich world, we make the non-emitting options so cheap that they're the obvious choice.
Right.
And the other option is that we really rethink what international assistance means and whether financial assistance for accelerating the transition in poorer countries is in the interests of the rich world because it decreases things like risks of political instability. And we may see some of that. And I suspect that if we see it, it will be in subtle mechanisms like changes in the way that the World Bank or the International Monetary Fund think about their loan portfolios. But one of the things we need to make sure of, and this is again in the spirit of building durable political coalitions, is that this isn't going to work if the rich world turns to the poor world and says, you folks have to impoverish yourself further by investing resources that you don't have in an accelerated transition.
Yeah.
I think there are likely to be decades when the rich world has made tremendous progress, may even have greenhouse gas emissions down to zero, when countries in the poor world will still tend to need to rely on fossil fuels for transportation and electricity generation and manufacturing. And we need to build that into the way we think about what the timing of reaching net zero should be. One of the things that I'm always frustrated at is that when we talk about the Paris compliant time goal being zero emissions by 2050, even the richest countries, the richest institutions tend to say, okay, well, I can make a plan to reach net zero by 2050, when if everybody needs to reach zero emissions by 2050, the richest actors need to be way ahead of that. And I think we still haven't stepped up to addressing that aspect of the equity challenge.
What role does a carbon tax play in this picture?
There are lots of ways you could think about incentivizing decreases in emissions. Economists tend to love carbon tax because it really lets the market sort out which approaches are going to be most effective and which are going to be wastes of money. And at least in principle, a carbon tax could be deployed in a strategic way that would be globally fair, that could really encourage the rapid deployment of the best possible technologies. There are other things we can do. If you look at the history of environmental regulations, we've actually made more progress with command and control approaches than we have with market-based approaches. So with the Clean Water Act, most of the requirements have simply said, you can't put this pollution in the water, or you can't pollute at a higher level than this. And there's nothing particular to say that a carbon tax would work better than a command and control approach. It really depends on what the politically enabling conditions are. There's been a lot of discussion recently about what's called a border adjustment, where a country with a carbon tax would say, okay, well, any product that is imported from a country that doesn't have a carbon tax has to pay a carbon tax at the border to the country that the product's coming into. And of course, that is a big boost for local manufacturing as well as for addressing the emissions associated with different products. And, maybe the concept of a carbon tax with a border adjustment will make it more politically palatable. My sense is that in the U.S., we're not very close to agreement on the value of a carbon tax, even though it could, for example, be used to produce a dramatic decrease in income taxes. And I think what's really important is that we come up with something that people can agree on politically and move forward with that and not let the perfect be the enemy of the good, even though carbon tax might be something like the perfect.
Finally, what are you expecting here if you had to guess what path we're going to take through the range of possible outcomes in terms of mitigating, failing to mitigate, creating political consensus necessary to mitigate, failing to do that? If you had to guess about what the world is going to look like in 20 years, 30 years, what are you expecting?
Well,
is there a degree of optimism or pessimism that's underwriting your current efforts, or are you just agnostic and doing what you feel we need to do in any case?
Well, I want to make it clear at the outset that I don't have any special insight into what kind of decision countries around the world are going to make. I am optimistic that the progress that I've seen in the past decade has been really consequential on what emissions levels are. In most of the rich countries, emissions have been decreasing on a year-by-year basis. I think they increased in the U.S. last year, but that was mainly a consequence of the decrease in the COVID pandemic activities. But in most countries, emissions are decreasing, and we now live in a world where electricity from renewables is cheaper than electricity from fossil. We live in a world where the most attractive transportation options for private vehicles are electric, and where heat pumps can improve the air quality in homes, and where we know that pollution from gas stoves is harming people. So lots and lots of indications that the technology is ripe for an accelerated transition. But there's still lots of pushback from vested interests, from oil and gas companies, from fossil producing regions of the world, and lots of need to work on the kind of political coalition that I've been talking about. I expect us to not achieve the very best outcomes, but to make the transition in a way and at a pace that's going to preserve a livable world. At least that's my hope. And what that might mean is that while we don't meet the Paris Agreement goal of stabilizing warming at well under 2°C above pre-industrial, we might end up pretty close to 2°C, maybe a couple of tenths above it. And there will be incalculable damage associated with not making the goal, but it's a lot better to be at 2 or 2.2 than 3.5 or 4. And my sense...
Do you picture some of those consequences being necessary as just for rhetorical effect to get us politically aligned enough to take this seriously over a time horizon that exceeds the 4-year presidential election cycle? I mean, it seems to me that to speak locally about the United States in particular, it's so hard for us to make any decision with a time horizon beyond 4 years politically that it could well take something so noxious and durable as a stimulus for us to say, okay, whatever our political differences, we have to be responding to this year after year after year. This is now a non-negotiable decrease in our quality of life. Are you picturing that being part of the process, where it just take whatever it is, wildfires or any other stimulus, it just becomes so onerous and obscene to be living with these consequences year after year that we just reset our politics around that?
Yeah, I have many colleagues who talk about the possibility that truly catastrophic extreme event, a Category 5 hurricane hitting Miami, or the kind of mega heat wave that Kim Stanley Robinson describes in Ministry for the Future. And it's possible that one of these truly catastrophic events will galvanize national and world opinion. My expectation is that it'll probably be a little more incremental than that the non-emitting technologies will continue to be cheaper and better and more attractive in the marketplace, that an appreciation that the climate change needs to be addressed will get nailed down with each wildfire and each extreme precipitation event, and that we'll just gradually transition to a much stronger focus on making progress in this than we have to date. And I think that a lot of that is going to be dependent on having this be a world in which there are opportunities for the kinds of individuals and actors that are not seeing opportunities now. And that's going to be things like energy producing states, oil and gas companies, individuals who currently work in manufacturing or energy production. And I just want to close with the thought that until we're really serious about these interests that are displaced by progress on climate, it's going to be really, really hard to come up with the kind of broad political coalition that we need. And we'll go more slowly as a result of not building out that coalition.
Well, Chris, thank you for the tour of the possible apocalypse. I feel much better educated and strangely more optimistic for having spoken with you. So thanks for what you're doing, and thanks for bringing your voice here on the podcast.
I enjoyed the conversation. Thanks so much.